A sound whispered at one focus of a whispering gallery can be heard at the other focus. The figure shows a whispering gallery whose cross-section is a semi-elliptical arch with a height of 24 feet and a width of 80 feet. How far from the room's center should two people stand so that they can whisper back and forth and be heard? Well, let's answer this question by putting the information that we have on an XY axis. So if we look at the information we have, we can put the center at the origin, 0, 0. And we can put each vertex of the ellipse, one here at 40, 0, and one here at negative 40, 0. And we see that the height is 24 feet, so put that 0, 24. So what we have here is our semi-ellipse. So if the center is at 0, 0, we know that the distance from the center to the vertex is always A units. So A is equal to 40. And the distance from the center to this end point is B. So B is equal to 24. Each focus is always along the major axis. So we'll have one focus here on the major axis and one here. We don't know exactly how far that is right now. That's what we're trying to find. Where should these two people stand? Well, the focus is always C units from the center. And remember, in an ellipse, we have the relationship that C squared is equal to A squared minus B squared. Remember, A is always larger than C in an ellipse, so if we have A squared and we subtract B squared, we'll get C squared. So we have C squared is equal to 40 squared minus B squared, which is 24 squared. So that gives us that C squared equals 1600 minus 576, or C squared is equal to 1024. If we take the square root of 1024, we get C is equal to 32. So now we're ready to answer our question. The question was, how far from the room center should two people stand so they can whisper back and forth and be heard? Well, they should each stand at a focus, so they should stand exactly 32 feet from the center.